Okay, so for this example, we're going to be doing both a vertical center of gravity shift and a transverse center of gravity shift for the same problem. Okay, and there's a little bit of Archimedes principle thrown in for good measure. So it tells us we have a DDG and it's floating upright and it displaces 278,000 cubic feet of seawater. So given 278,000 feet cubed seawater displacement. Okay. It then tells us the vertical center of gravity is 15 feet above the keel. So kg old is 15 feet. Okay. It tells us it's floating upright with no list. Now, anytime the problem statement says floating upright or zero list, that is also saying that the transverse center of gravity is equal to 0. All right. It then tells us we move an engine from the engine room to the flight deck for offloading. So the first part is we're going to remove engine from engine room. Okay, it tells us that the weight of the engine is 50,000 pounds. So for this, that's going to be a negative 50,000 pounds because we are removing the engine. Weight removals are negative. It then tells us that the initial position was 10 feet above the keel. So kg was positive 10 feet. And that the position was 20 feet starboard of center line. So TCG was positive 20 feet, starboard side. It then tells us that we place the engine on the flight deck. Place engine on flight deck. Okay, so adding the engine is now a positive because it's a weight addition. So our W is going to be positive 50,000 pounds. It then tells us that position on the flight deck is 40 feet above the keel. So kg is equal to 40 feet. And it tells us that we place it on the center line on the flight deck. So on the center line means that the TCG, transverse center of gravity, is 0 feet. So that's all of our given information. It then asks us what is the new vertical center of gravity and the new transverse center of gravity. So the first thing we have to do is we're given the displacement of the ship as 278,000 cubic feet of seawater. Well, the engine weight is in pounds, so we need to get the displacement of the ship in pounds as well. So going back to Archimedes' principle, displacement is equal to the specific weight of the fluid, which in this case is seawater, times the volume of that fluid that's displaced. So specific weight of seawater is our good old 64 pounds per foot cubed. It tells us we're displacing 278,000 cubic feet. Therefore, the weight of the ship is 1.78 times 10 to the 7th pounds. Now you could go ahead and convert everything to long tons if you wanted to, but our engine weight is in pounds and we have our displacement in pounds, so we already have consistent units. So I'm just going to go ahead and do it in pounds. So for our new vertical center of gravity, that's going to be equal to our old vertical center of gravity times our old displacement plus the sum of all of our weight changes times their positions, all divided by the old displacement plus the sum of all the weight changes. So we can go ahead and just start plugging everything in. Our old vertical center of gravity was 15 feet. Our old displacement, 1.78 times 10 to the 7th pounds. And then we do our weight changes. So our first weight change was the negative 50,000 pounds from a position of 10 feet and a positive 50,000 pound addition at a position of 40 feet. And then all divided by the old displacement, 1.78 times 10 to the 7th pounds, minus 50,000 pounds, plus 50,000 pounds. And if we plug that all into our calculator, we get that the new vertical center of gravity is 15.08 feet. All right, so now we can do the same thing for transverse center of gravity. TCG new equals TCG old displacement, plus the sum of all the weight changes all over old displacement plus sum of weight. All right, so again, we just work our way across. So the old transverse center of gravity was 0 feet times the old displacement, 1.78 times 10 to the 7th pounds, plus the first weight change of negative 50,000 pounds times the transverse position for that weight shift, which was the positive 20 feet, plus the second weight shift adding 50,000 pounds to the flight deck times the position of 0 feet all over 1.78 times 10 to the 7th pounds minus 50,000 pounds plus 50,000 pounds. Plug it all in and we get a final transverse center of gravity of negative 0.056 feet. And again, transverse center of gravity, negative means port side. So hopefully from this you can see that these problems don't necessarily get much more complicated. There's just a lot of numbers that you need to keep track of, and you need to make sure that you have a system for tracking which numbers go where so that you plug them in the right spot. And that's all there is for this one.